Moving on to our next shuffle, which is called a Monge, M-O-G-E shuffle. It comes in two varieties, an over-under and an under-over, as you will see. So this is a very popular shuffle and can be used in a variety of settings to, quote, randomize the cards in a way that many of the other shuffles do not. Okay? So it's a great shuffle to be aware of and understand, at least to some degree, what this shuffle is doing to the ordering of the cards. Okay, so let's go ahead and see what this shuffle is doing. So as always, we begin with an ordered packet 1 through 8, and then we will look at the effect of the shuffle on this ordered packet. Okay, so what is a Monge shuffle? Well, you push over the top card. Now this is an over-under, so what that means is the next card right here goes over this one, the next one now goes under, then over, under, over, under, over. So that is a Monge over, under. So what is the new ordering that we get? Well, it's 8, 6, 4, 2, 1, 3, 5, 7. So if we come down here, that's what I've written up for the Cauchy two-line notation for our permutation. It's going to be 8, 6, 4, 2, 1, 3, 5, 7. And we can convert two-line notation to one-line notation, which is also called cycle notation. Okay, so let's step through that quickly. So 1 gets sent to 8. Where does 8 get sent? 8 is sent to 7. Where is 7 sent? 7 is sent to 5. And then where does 5 go? 5 is sent to 1. So it wraps around. So we're looking at a 4 cycle here. Okay, what about the remaining position values? Well, 2 gets sent to 6. 6 gets sent to 3. 3 gets sent to 4. And then 4 gets sent to 2, which wraps around and completes that cycle. So it looks like we have 2 cycles of length 4, or 2 4 cycles as we call them. Okay? And that actually accounts for all of the position values. All 8 positions are now accounted for. Now, if we color code this, we obtain the following, which is quite interesting. So we can see here that inversion has occurred this time. Remember, the position values 1, 4, 6, 7 are color-coded black. The position values 2, 3, 5, 8 are color-coded red. And so we can see that there's an alternation of the colors once they've been color-coded correctly. So what this will mean then is what was in position 1, so black 1 goes to red 8 goes to black 7 goes to red 5. This wraps around and goes to black 1. Red 2 goes to black 6, which goes to red 3, which goes to black 4, which gets sent to red 2. So inversion has indeed occurred. Each value gets sent to a value of the opposite color. So because inversion has occurred, we should not be surprised by the effect of this shuffle on our standard Bessey sequence if we begin with 1 as the leading digit. So if we begin with a Bessey sequence of 0s and 1s and perform this shuffle, we will get the inversion of this sequence. So why don't we just quickly show that. So a Monge over under, you push over the top card. The next one goes over, under, over, under, over, under, over. Okay, so has inversion occurred? Well, it looks like it has. We had 1, 0, 0, 1, 0, 1, 1, 0. Now we have 0, 1, 1, 0, 1, 0, 0, 1. Now, unlike the last shuffle where we had a couple of fixed points, that does not happen here. So here we can genuinely say that the cards labeled with 1s will genuinely move around among themselves each time you shuffle a packet of 8 cards, and the cards labeled with 0s will move around or permute among themselves each time you perform this shuffle. Okay, so there's no fixed points. Cards are moving around. Now, it is true that this is a shuffle of order 4, right? So if we perform this shuffle 4 times, it resets the packet to its original order. Okay? Now let's go ahead and take a look at the graph, because this is a very chaotic looking graph here. So we know that 1, so here is 1, 1 goes to 8, which goes to 7, which goes down here to 5, which goes up here to 1, and that completes that cycle, that 4 cycle. That's also called an orbit. And then 2 gets sent to 6, which gets sent to 3, which gets sent down here to 4, and then 4 is sent to 2, completing that cycle of length 4. That's also an orbit. Now, if you look at the messy nature of the movement of the cards in these various positions, it should be rather surprising, as we'll see, both in the over-under and under-over are Bessey shuffles, meaning they preserve or invert, as is the case here. Inversion occurs. They preserve or invert Bessey sequences. And then I have a note down here that this particular shuffle is the inverse of shuffle 19 that we'll look at in a future video.